You guys, I haven't seen you since Friday, which feels like a decade ago. And on Friday, we talked about taking these derivatives of integrals. And you've already filled this part in, which is great. We're on page 16. What happens with the derivative of an integral? They cancel out. And you're left with, let's remind ourselves, you plug in page 16, the upper bound. And then what do we multiply that by?
Chain rule.
That's right, the derivative of that upper bound. What happens when I then subtracted, plugging in my lower bound, times the derivative of that lower bound is 1, gets me nothing. We use the chain rule, and you've already written that. Great. This would have been my answer. Great, we've done D. Fabulous, let's go E. What did I do to trick you on E?
You put the function on the bottom.
Yeah, right.
The one thing.
Yeah, he goes, ooh, the derivative of an integral is still going to cancel out.
The front half is going to cancel.
Do I really need to write the tangent of 1?
No.
Why do I not?
Because then you multiply by the constant.
The derivative of 1 gets me
0.
perfect. So I really don't need that. Why might it help us? What symbol do I have to put here now? Minus, very good. Negative, love it. What am I plugging in then? Tangent of times, beautiful. Could their pretty print answer be this? 3 times the tangent of 3x.
Yep. Negative.
No, it needs negative.
Thank you. Now it's right.
Donkey Kong.
Exactly. We got Donkey Kong or King Kong. This is King Kong. We're going to go away from Donkey Kong. The altitude. And I gave you the altitude as an integral. And we're not used to that. This is kind of new since we've seen this integral symbol. Healed. Here we go. What is the rate of change of the altitude? Rate of change is just means the derivative. Can I take the derivative of that integral? Well done, you guys. So if they want the rate of change of the altitude, I'm looking for h prime. What would that be?
It's just 64 minus 12.
Yes, 64 minus 12. Careful, careful, careful. Plugging in that upper bound gives me a 12t. Times the derivative of t would get me a 1. We don't care about it. Minus plugging in the 0 times the derivative of that lower bound would be another 0, so we don't need it. You guys, that is the rate of change of the altitude. Then they said, hey, what is that at 4 seconds? Just plug in 4.
Oh, all right.
What is h prime of 4? 64 minus 12 times 4. 64 minus 48.
Wait.
When do they stop going up and start coming down? Here's what you got to think about. Woo, when what changes from positive to negative? H prime, she's exactly right. You guys, do you agree if I move to the right, what's my velocity?
Positive.
If I move to the left, what's my velocity? Negative. So let's go find out when they equal 0. It's because to go from a positive to a negative, we got to cross through 0. Let's go see when my h prime equals 0. Let's go see when my 64 minus 12t equals 0. So many yawns. Here we go. 64 equals 12t. Without a calculator, let's simplify that. 64 twelfths.
Is, hold on, let me count. 8. No.
I like your method. That's good, Soph.
1630.
Yeah, and we're talking seconds, right? And this one was going to be feet per second. Not that they asked, but since that one was a rate of change, we're going to say feet per second. And this one just said at what time? 16 seconds. This is a little s. Yeah, stickers for this one. See how you do with getting the derivative of this integral. Go for it. So on this one, when we you're like derivative of an integral, cancel out. And then this is what costs a lot of people, which is why they do it. We have to do 2x that quantity, then cubed, plus 1 times the derivative of that bound, which gets me a, minus, I would have to plug in a 0 there, times the derivative of 0 is going to cancel out. So this is what I've got to do. What is this? I want you to know, this is not the same as that. Because isn't this, meaning I got to cube my 2? 2 times 2 times 2 is going to get me 8. So I'm digging these 8s here. And so my final answer is going to be D. In my last class, a lot of people chose B. What's wrong with B?
2.
They forgot the chain rule, which is so easy to do. Like they expect us to do that, okay? It's a no problemo. Let's try this guy. What if we've got this? We've got this. What if...
Actually do it.
Well, yeah, so he says just do it. We'd plug in sine of x to my function. So that would be the f of sine of x. What would we have to multiply that by? Well done. The cosine of x is the derivative of that upper bound. Then what do we have to do? Minus f of 2x times 2. Good job, you guys. That's just chain rule. This guy is preparatory for this AP test question. So, did I do the same thing to you, Nelson? Do they both have x's? Yeah. So, you guys, if they want h prime of 1, let's just start with h prime of x. It does. Just like Carrie said, we always do the top one first because you want to be on the top of the podium. You know what I'm saying there? Yeah, we do. Okay, what happens when I plug in an x cubed right there? And maybe we just practice it like that. Root 16 minus, just throw that x cubed and then square it. Who cares? You could simplify that to x to the 6th if you want, but you don't have to. Ooh, do we have to multiply that by something? Beautiful, you guys. Minus, sorry, that 3x squared was the derivative of my up. That's okay. Then we got a root 16 minus 3x squared, well done, times the derivative of that, which is 6x. You guys, I wouldn't simplify. I'm just going to go plug in a 1. We found h prime of x. Let's go find h prime of 1. H prime of 1 is going to get me root, what would be under my root? 15. 16 minus 1, right? 1 cubed. Sure. Yeah, that's a good call. Times, beautiful, minus, ooh, this one's a trick. This one's a trick. Ooh, it'd be 3 squared would get me a 9 in there. 16 minus 9 is root 7. Times plugging in a 1 over there would get me a 6. Yeah. So if this was free response, to Graham's point, we would have just plugged in the 1 and not simplified anything. If this was multiple choice, this is what their answer would have looked like. Yeah. F prime of x is just going to be x cubed plus 1. And then they wanted f prime of 2 is going to get me 2 cubed plus 1. That's going to get me square root of 9, which is going to get me 3. So as we look at 6.5, we're on page 18 now, back in our blue notes. Check this out. So 6.5 is all about applying what does this integral symbol mean now. So it says, hey, what makes the values the greatest of g? So you guys, if we were to think of a function, if this is a function, what would you call this right here? If that would be the max. What makes a max? When, if this is my function, f, when f prime goes from positive to negative. You guys, if they're looking for the greatest and we're talking about g, wouldn't that be when g prime goes from positive to negative? Okay, could I go get g prime? Yes. G is an integral, therefore what would it g prime be? Well said, Nelson. He goes, okay, derivative of an integral cancels out. I got to plug in my upper bound times the derivative of my upper bound would just be a 1. Minus plugging in my lower bound, but times the derivative of that lower bound, that which is a constant, is going to get me 0. Guys, they're going to ask this all the time. They're going to want, this is going to be all the time. So just us getting familiar with that is huge today. And you guys, just, I think that this is another good reminder. What makes something the greatest? I'd say g prime or f prime goes from positive to negative. Look what you just wrote. You just said, but hold up, g prime is f. What graph did they just give us? G prime is the same thing as f. So where does f go from positive to negative? Yes, positive 0, negative, that's happening at 1. Boom. You're saying when my x value is 1. We can do that. We can handle that. Okay, let's take a peek at this guy. They said, hey, here's f, and f is this integral, which could be the graph of g. You're like, what? Where'd g even come from? Oh, g is right here. How could I get rid of that integral? Yeah, what would f prime be? It's just going to be g of x. They said, you guys, all I gave you is a graph of f, which could be a graph of g. So if f prime is g, talk to me about my f prime. It's always positive. So you're saying f prime is positive. What? Okay, so wait, what are we getting rid of? We're getting rid of D because that's negative. We're getting rid of E because that has negatives. And this one's also below. It is A. How did you know it's A versus C? Yes, wouldn't you agree f prime is constantly positive? What would, if my f prime, this would be increasing, agreed. So because my f prime is constant, if you were like, oh, we rose like 1, rise 2, like if my slope here was a half, my value here has to be the constant half the whole time. That's why it's A. But it would be very tempting to choose C. The reason why we cannot is because this graph of G, these Y values would be getting bigger. My slope here was constant and they weren't getting bigger. Good call, you guys. Good job. Let's flash back a little bit. When a derivative is increasing, when the slope is increasing, you're thinking it's going to be concave up. A concave up thing looks like this. What's my slope here? And then positive. If I go from negative to 0 to positive, are those slope values increasing? Agreed. What about if a derivative is decreasing? Okay, bless you. If my function is concave down, what's my slope here? And that means my f primes are decreasing. Well done. Ooh, does anyone remember this one? Blast from the past. Wait, what? Point of inflection is when that derivative has a max or min. Again, we haven't talked about that.
I preferred POI was probably really reals.
I love reals.
If you guys want a reminder how we actually find that another way, it's just when that second derivative changes signs. These are just blasts from the past because we're going to use them now.
What if I had like
You guys, look at these answers. We got to use a calculator. Check this out. We haven't seen one like this yet. It says, hey, the position is X. And then they said, I started at 2. So you guys, that's like at the track. You're going to give me a little leg up, right? You're going to let me start, I don't know, maybe 200 yards in front of you, okay? This is saying at the time started, I didn't start at 0. I started at 2. You're like, she's old. I had 2. Give her a step up. You guys, then I said the velocity is given. What's the position when t is 3?
Surely there's an integral button.
Exactly. Listen to what you just said. Clearly there's an integral button. You guys, how do I go and find velocity? You with me, Healed? If I'm given velocity, what's the integral of velocity? It goes backwards. It gets us that position, you guys. That's so good. So, you guys, here's the deal. If we were to say, hey, this is saying the integral of velocity equals position. If I integrate my velocity, what would be my bounds? Thank you, bud. Yes, she says, okay, I'm going to start at the beginning when t is 0, and I'm curious how far I went over that time interval to 3. There's a trick on this, though. That's going to get my distance traveled from 0 to 3. That's going to get my distance traveled, but they're asking where I'm going to end up. Do I need to take something into account? Exactly. I'm just going to throw a 2 either at the front or the end. Let's go do that in our calculator. Let me remind you how to do that. Thanks for getting one. If yours is dead, no problem. Grab one of my yellows. Let's go, and we're going to say 2 plus math 9, 0 to 3. The cube root is math 4, 1 plus x squared dx. Perfect. You guys, if we didn't put that 2, do you agree that they have the answer?
Starts at 2.
Okay, perfect.
Like when time is 0, it is
It's
2.
2.
Right. You guys, I love this question. This is an AP question that is 9 points, people. Every AP free response is 9 points. And let's go see how many of the 9 we can get. If you can get 3 or 4 points on every free response, you're going to get a 3 on the test. Don't mind if we do.
Let's go.
We need a third. 33 to...
Structure, sorry.
So, you guys, look at this. They gave us a graph of f, and they said g is the integral of f. Find g of 3. Would you guys agree this x was replaced with a 3?
Yes.
Could I replace this x with a 3 then? Yes. Sure could. Let's go do that. So just like Dicey, you had said earlier, you're like, okay, G of 3 is just the area from 1 to 3. Because did they ask us to take a derivative or anything on that? They didn't, right? So Dice, like you said earlier, anytime you're given that integral and a graph, that just means find the area. What shape are we dealing with here, guys? From 1 to 3, isn't that triangle over there? Area of a triangle is 1/2 base times height. It's below the x-axis. You would think that we got to make it negative as opposed to positive because it's below. So I'm going to say negative 1/2. My base is how big? 2, and my height is, again, if you were to interchange those doesn't matter. Close. Negative 1. Wah, wah. Okay, this is good. This is putting it all together. Here we go. Find the x-coordinate where G has a horizontal tangent line. You guys, as soon as you see the word horizontal,
Zero.
what's 0?
X.
The slope.
Oh.
Where G has a horizontal tangent line.
At X equals 0.
Y is constant.
We're looking for G prime equals 0, right? Isn't the slope of G prime?
No, I'm just saying.
And we got to go find out where. Oh, I see what you're already looking at the end. I see. Okay, I got you. So it said, hey, find the x-coordinate of each point where G has a horizontal tangent line. I need you to know, you writing this gets you a point. You writing that right there is 1 point. Because you're telling them, I know that's when G prime has equals 0. So let's go find out. So, sorry, you said that G prime equals 0 at 0. How are we even getting G prime? What would G prime of x be if this was G? F of x, exactly. This right here is another point. We like that.
Yep.
We like that. So, Graham, when you said when G prime equals 0, wouldn't that be or also when F is 0?
Yeah.
Okay. On this graph, where is, on this graph of F, is my F equal to 0? Negative 1 and 1, right? At X is negative 1 and 1. Cool. Find each of these points. Did it. Then at those points, at negative 1 and 1, tell if we've got a relative min, max, or neither. So what makes a function, picture this. Ooh, what makes a function have a min?
Negative to positive.
What goes from negative to positive?
F prime.
F prime goes from negative to positive. You guys, in this case, you agree it'd be G prime goes from negative to positive? Well, G prime is the same as F.
Well, F. So F positive.
Okay. So at negative 1, what are my F values the same? Sorry, what are my F values going from? A max, exactly. So you guys, we're going to go say relative max at X is negative 1 because, do you want to say G prime changes from positive to negative?
Yes.
F equals changes from positive to negative? You could say either one because we've said that they're the same, or you could just say the whole thing. Because G prime, which is the same as F, goes from positive to negative. But if Colin only put G prime goes from positive to negative, you get 100%. If Graham, you said F goes from positive to negative, you get 100%. If Hetler's like, I already said that, so I'm just going to keep it consistent, you get 100%. Sound good? You can only interchange these if we've stated that they're equal earlier, though. What's going on at 1?
Nothing.
Neither. How do we get to say, yeah, because look, it says, determine whether G has a neither. Yep. We're going to say neither at X is 1. Why? Yeah, what doesn't change signs? If you say it, I'm going to puke. F or G prime, either one that you want to say, doesn't change signs. It went from negative to 0 to negative. Doesn't change signs. They don't need all that. You're good with just doesn't change signs. Sammy, we're back to this point of inflection. What makes G have a point of inflection? When G double prime changes signs?
So it's the slope of that.
Okay, so here's the deal. This right here, when it says explain your reasoning, boom, we got our point right there. They're saying for what values of x does g have a point of inflection? You guys, we don't even know what g double prime is, but let's look back here.
It's F prime.
If g prime is f, isn't g double prime going to be f prime? Awesome. How would I get f prime from a graph of f? Find the slope. What's my slope over here? Positive. What's my slope here?
-2.
Yeah. So can we say at x is -2? Because my f prime went from positive to negative. What about from here? What's my f prime here?
Negative.
What about right here?
Still negative.
Still negative. Well said.
Oh, it's F0.
Ooh, what about there? So you were looking at earlier, you were having a premonition. You're saying at 0, my f prime would go from negative to positive. Love it. And then my f prime was,
Positive.
and then
So at 1.
at 1 as well. So, did they ask where my g double prime doesn't exist? Do you agree my g double prime is undefined at -2 because we've got a corner? They didn't ask that. We're saying I know points of inflection is just where my g double prime changes signs. I don't care that we've got a corner there. It went from positive to negative, so it changed signs. We're good. Here's the deal. What do we have to do on this guy? They said, hey, what's g of 5? What am I replacing?
X with 5.
Yeah, that x is getting replaced with a 5. So we'd say g of 5 is just the integral from 0 to 5 of f of t. And they gave me a graph of f. So what do I need to do?
Find the area.
Find the area from 0 to 5. Because they didn't ask for a derivative, right? It's not canceling out. Find the area from 0 to 5.
I got you.
You guys, you want to know why I hate this question? Don't you think most people would be like, well, there's from 0 to 5. Well, I would just go like this. If I didn't look closely enough, I would do it from -2. Those weasels, they just put that extra part of the graph and we're going to not even use it. You know what I'm saying? See at the answer. Triangle and half a circle.
Can you do circle again?
Just do the circle.
Pi r squared and then half of it.
Radius is 2. Questions?
Here we go. Last page, page 20. Okay. What makes a function have a maximum? What makes g have a maximum? What goes from positive to negative?
Double.
Ooh, g prime goes from
Oops.
positive to negative. You guys, they said, here's a graph of f. And you're like, dude, I need g prime.
So G.
F is g prime. He's like, okay, the derivative of that integral, I'd say g prime is f. Well said. That is hit on the AP test. Foshizi. You guys, a maximum is when g prime goes from positive to negative, but g prime is the same as f. Where on this graph does g prime or f go from positive to negative?
3.
Boom.
Only.
Okay, here we go. This one, is no calculator. Gross. You know what? I'd rather do this one first. Let's do this one first and we'll end on that guy. Here's h. Where is h increasing? What makes h increase if h prime is positive? I'm looking for when h prime is positive. Could I get h prime from this info? Sure, this is the ugliest function. Gross. What would h prime, and maybe we even just put it right here. What would h prime be? The derivative of that integral?
2x.
2 plus 2L.
2 plus 2 ln of x. Gross. Times 1. Minus plugging it all in times 0. So this is my h prime. You guys, you said with a calculator, we need to go figure out where h prime is greater than 0. We have h prime. Everybody, go to that y equals screen, please. We have h prime, so we're going to go graph that. 2 plus 2 ln of x. And we need to change our window. Our window we're going to want from 1.1 to 7. Go change your x min and your x max to be 1.1 to 7. Yeah, does your graph look like mine?
Wouldn't you want to make it a little bigger than the 1.1 to 7?
No, because they actually confined it.
It's probably B.
So it's, we only want that.
Well, I mean, you can kind of.
You guys, you said when h prime is positive, this is a graph of h prime. Where do we want that?
It's B.
Greater than 1.
Anything above that x-axis, well said.
The answer is.
You're like, I feel very confident that that zero, that's a good time saver. If I did do second trace 0, and I go to the left of that 0 and to the right, Graham feels good because it's going to be that 1.445, and we're saying everything to the right of that. Well done.
So F prime is.
This one is the same idea with no calc. Ready, healed? When is F increasing? When F prime is positive. Well done. You guys, they gave us F. Can we go find F prime? Sure. F prime of X is going to be
Negative X squared.
beautiful, plus 2X, plus 3. Times the derivative of that upper is 1. We don't need to worry about the bottom.
Oh, because you just take out the interval.
You got it, bud. So you guys, without a calculator, if we're looking when my F prime is positive, we got to go set it equal to 0 because anything that's positive will be above 0. Here's the deal. Toot is so much easier than O-toot. So let's factor out a negative so that I can toot it instead of O-toot it. What would be left if I factored out a negative?
X squared.
Then?
2x minus 3.
Thank you. You sounded like a Siri response. Could we toot this now? Heck yeah, we can. What multiplies to be negative 3 and adds to be negative 2?
Probably negative 3 and 1.
Negative 3 and 1. You guys, the reason that this is really good is we haven't done this stuff since Unit 5, and this is going to come back in Unit 6, so we're just reviewing. Because, you guys, we got to set these equal to 0. What are my x values? 3 and negative 1. And you want to know what we got to do? A sign chart. What? We haven't done one of those in a while, so here's why I wanted to do it again.
Does that negative have any? Why do we have?
Yeah, I'm going to show you why we have that negative.
Because you have to know when it's greater than.
Yeah, for my F prime to be greater than 0, yeah, we got to go see when the F prime's positive. So you put your critical points on our number line. I like to put squares around them so I know my answers are based on these values. And you can see we got lots of negative 1s and 3s in my answers. You guys, what's the number that we want to try that's less than negative 1?
2.
Negative 2. Between them?
0.
Bigger. Great. Just as a reminder, because we haven't done this in a while, these are x values. We're going to plug them into the derivative to see what's going on with my function. Again, I do not expect you to be like, oh my God, I totally remember that sign chart. This is just a good reminder. You guys, we always plug these values into the derivative. So I'm going to plug it there and there, but I am going to be mindful of that negative that we factored out. If I plugged in a negative 2 here, what would this be, positive or negative? Negative times a negative is a times that negative. Whew. If F prime is negative, that means my function is decreasing. Well done, you guys. If I plugged in a 0 right here, 0 minus 3 would get me a negative times a positive times a negative is a positive. They asked when F prime was increasing. I feel good about that. What if I plugged in a 4? Times a positive times a good, you guys. So from what x to what x, yeah, is my function increasing? Boom. So this is great, you guys. Your only homework, you're going to finish this splendidly, is page 7 then. So we'll have 6 and 7 done. I'm going to put the answers to page 7 up here because I didn't put them on yours, so I apologize about that. The answers to page 7 are...
Which one is these are